Okay, so we've looked at values of angles that were acute angles, right? So acute angles being where theta was greater than 0, well, greater or equal to 0 degrees and less than 90 degrees. And we've looked at these acute angles and their particular trigonometric ratios. However, what if we have angles that are obtuse? So if angles are obtuse, they're greater than 90 degrees, but less than 180 degrees. Okay, so what if we have obtuse angles? How do we determine the value of their trigonometric ratios, right? And the way we do this is we use something called a correlated angle. And the correlated angle, we're basically going to be looking at relating these angles to a related acute angle. How we're going to determine this is we need to go back and investigate our angle in standard form. So I'm going to draw out a Cartesian plane again. Okay, and recall that angles in standard form, we have an initial arm that's located on the positive x-axis. Okay, so this is our initial arm. And we looked at angles as degrees of rotations, specifically positive angles were counterclockwise degrees of rotation from the initial arm outwards. And we can represent the point of the terminal arm, x and y, so this was the terminal arm, to look at the position of the terminal arm from the initial arm. We can thereby figure out its angle, theta. Okay. Now we also looked at some of the primary trig ratios associated with this angle theta. We can understand that sine theta is basically the opposite side over the hypotenuse. Well, if we have a point x and y, this is the dimension x, this is the dimension y, sorry, and this is the dimension x. We know that the terminal arm will eventually become the radius of the circle if we have a full circle. Okay, so this is the radius. So the sine theta here, because x and y are 90 degrees to each other, sine theta is the opposite side over the hypotenuse being the radius, so we have y over r. You notice that these are both positive. Okay, so we're in the positive y. Radius is always going to be positive. Okay, so positive r. Cosine theta it's the positive x value over r, and tan theta is y over x. Okay, so these are the primary trig ratios in the first quadrant. So this is basically quadrant 1, right? And you can think about the reciprocal ratios as just the reciprocal of these. You just flip the numerator and denominator. Now if we wanted to look at an angle in the second quadrant, and this is basically what an obtuse angle is, right? This is going to be found in the second quadrant, and the terminal arm would be found positioned, whoops, let's say that it's found positioned here, okay? I didn't draw this exactly the way, so let's say that we took the same terminal arm and we positioned it in the second quadrant. Let's say it's here, okay? Okay, so now we're going to have the point negative x and positive y. Okay, so this is negative x because this is in the negative, it's in the negative portion of the x coordinate, and we have positive y. And in this case, the angle would have a rotation that coincides with this value, theta. Okay, now this is an obtuse angle. However, we don't have particular ratio, that we don't have these well-known particular ratios for these obtuse angles. What we could do, however, is we can relate it to an acute angle, and this related acute angle, I'm going to call this beta, can be found here. Okay, so I'm going to use beta as my related acute angle, and we can use this related acute angle to make inferences about the obtuse angle. Okay, so theta. Now we can understand that if you do a full rotation from the initial arm all the way to this point here, this is a 180 degree mark. Okay, this is a 180 degree mark. So whatever our value of beta is, we can understand that theta is equal to 180 degrees minus beta. Okay, so keep this in mind. Let's take a look at the trig ratios for beta. Okay, so let's start with the sine ratio of beta. Okay, so the sine function of beta here is basically, and once again the radius is still out here, it's the length of the terminal arm. So the sine beta here is the opposite side over the hypotenuse. It's basically y over r. You can see that it's the same as sine theta, right? Cosine beta, however, is basically negative x over r. Okay, so we can notice that the sine ratio of beta is the same as sine theta, but the cosine ratio of cosine beta is equal to negative cosine theta. Okay, and the tan ratio of beta is equal to also negative tan theta. Okay, maybe just get rid of this. Negative tan theta. Okay, so what does this imply? Well, we know that theta is equal to 180 minus beta. So this infers that because sine beta is equal to sine theta, because they're both equal to positive y over r, this implies that instead of writing sine theta, I'm going to write 180 minus beta. Let's try to keep it consistent. Is equal to positive sine beta. Okay, so whatever our acute angle is, 180 minus that acute angle will give us the same value. Okay. We can notice here also that cosine 180 degrees minus beta, because it's cosine theta, right? I'm going to make the right side completely positive, is equal to negative cosine beta, right? So whatever the obtuse angle is, it's going to be equal to negative value of the related acute angle, beta. Okay, and tan 180 degrees minus beta is equal to negative tan beta. Okay, so I'm going to make sure that the left side is completely positive. Okay, so these are my correlated angle equations, right, in quadrant 2. Now, what's the relevance of this? Well, let's say that we had a value. Let's say we had to evaluate what sine 150 degrees was. Okay, and we can notice here that 150 is an obtuse angle. So this, we know that because it's obtuse, it's going to be found in quadrant 2. Well, we understand that theta here is 150 degrees, and we know that in the second quadrant, the correlated equation here, sine 180 degrees minus beta is equal to positive sine beta. Okay, so we understand this. And if we plug this in, we understand that theta here is equal to 180 minus beta. So in this case, theta here should be equal to 150. So all of this here should be equal to 150. And if theta here is 150, then 180 minus beta should be equal to 150. Beta should be equal to 30 degrees. If I rewrite this equation, sine 180 degrees minus beta here should be 30, should be equal to sine 30 degrees. So you guys can see that this is how the equation can be used and set up and for it to work, right? So you can actually notice that sine 30 is one of the special angles that we calculated, right? So sine 30 here should be equal to a half, and as a result, sine 150 degrees is equal to positive a half, and it's the same value as sine 30. That's how we can use related acute angles to figure out the values of obtuse angles, right? And if the obtuse angles have some relationship with the special angles, we can find their exact values. Okay, so in the next couple of videos, I'm going to show you guys the correlated angle equations for the third quadrant and the fourth quadrant. Okay, continuing on our discussion of correlated angles, right? Recall that we were looking at angles in standard position. Okay, and we looked at the second quadrant. Let's say that angles are now located, well, now the angles are greater than 180 degrees, but less than 360 degrees. And these types of angles are called reflex angles. Okay, so let's say that we're specifically looking at angles in the third quadrant, right? So the initial arm is always positioned on the positive x axis, and the terminal arm would be located somewhere away from that. So let's say that the terminal arm here is located, say, out here, okay, and this is your terminal arm, and in this case this is a reflex angle. So the reflex angle itself would be right here, right? So this is the reflex angle of theta, right? We don't have to color this in, but this is the reflex angle of theta, and it's located out there. And we want to find the value of particular trig ratios of a reflex angle. So the way we do this is we need to find a related acute angle. Now the related acute angle has to be created with the x-axis in question. And it's basically, we're going to project this initial arm here. So this is your value of your related acute angle beta. So remember that beta here is your related acute angle. And if you wanted to look at identifying your angle, your reflex angle theta, in terms of beta, you can write theta as 180 degrees plus beta. Right? So if you add 180 degrees, so 180 degrees would basically mean all of this. If you add 180 degrees plus beta, then you basically will get theta. Right? So that's the idea, really. So theta is 180 degrees plus beta. And recall that in the first quadrant, right, if we had a terminal arm that was located in the first quadrant, such as here, I'm just using a different color so we don't get it confused, but say that our terminal arm was in the first quadrant, we stated that this point here is x and y. We stated that this was the radius, this is the x coordinate, this is the y coordinate, right? And the ratios as follows: if this is theta, right, sine theta was equal to y over r, cosine theta is equal to x over r, and tan theta was equal to y over x. And all of these were positive, right? So let's take a look at beta here. Okay, so if theta was in the first quadrant, if it was an acute angle, these would be the ratios. Now let's compare this with related acute angle beta. So if we look at this point here, this is going to have a point negative x and negative y. So this is going to be negative x here, this is going to be negative y, and this would be r, right? And assuming that the length of r is the same in this case, I know it's not drawn to scale. If we took a look at that, we can note here that sine beta is equal, is equal to opposite side negative y over hypotenuse radius r, right? And this was actually equal, so sine beta in the third quadrant, you can actually see that the related acute angle is equal to negative sine theta. Okay. Now if we take a look at cosine beta in the third quadrant, we can see that it's equal to negative x over r, which is the negative value of cosine theta, so negative cosine theta. And tan beta, which is basically negative y over negative x, is equal to positive y over x, which is the same as tan theta. So just from this, in the third quadrant, our following equations will be as follows, right? So in the third quadrant, so this is your second quadrant, sorry guys. Right, in the second quadrant we said that only the sine ratio is positive. In the third quadrant we can see that sine theta, which theta is going to be 180 plus beta, sine theta, which is 180 degrees plus beta, is equal to negative sine beta. Okay, cosine 180 degrees plus beta is equal to negative cosine beta. And only tan was positive in the third quadrant. So 180 plus beta was equal to positive tan beta. Right? So in the second quadrant we found that only sine was positive. In the third quadrant, we found that only tan is positive. In the first quadrant, all of our trigonometric ratios are positive. Okay? Now, how do I use this? How do I go about using these equations? Well, let's say that we had a related acute angle that was related to a reflex angle that was basically a special angle. Let's say that we wanted to evaluate for the value of, let's say we wanted to figure out what is cosine, let's do 240 degrees. Okay, what is the value of cosine 240 degrees? Well, what we have to do here is we know that 240 is between 180 and 270, and we can understand that the third quadrant is between 180 and 270 degrees, right? Excuse me. And then we can utilize this correlated angle. So we know that this correlated angle equation. So we know that cosine 180 degrees plus beta is equal to negative cosine beta. Beta is your related acute angle. Let's figure out what that related acute angle is. So we understand that this is theta. So theta here is 240 degrees. And theta is the same as 180 plus beta. So this should be equal to 240 degrees. So this tells us that 180 degrees plus beta is equal to 240 degrees. Beta therefore should be 60 degrees if you solve for this, right? So therefore cosine, right, maybe use the different color here, but 180 degrees plus beta in this case is 60 is equal to negative cosine. Beta in this case should be 60. It's kind of like a function in a sense, right? In this case, we get cosine 240 degrees is equal to negative cosine 60 degrees, and we know that cosine 60 is 1/2, so cosine 240 is equal to negative 1/2. Okay, so that's actually the value of cosine 240. If you guys if you guys are skeptical, just punch it into your calculator and you'll actually get the same value of negative 0.5. Okay, so you can use these correlated angle equations to determine the exact value, or by exact value of the reflex angle counterparts if they are special angle equivalents. Okay, so in the next lesson I'm going to show you guys the correlated angle equations in the fourth quadrant, but what you want to understand from all of this is that in the third quadrant only the tan ratio. Alright, continuing on with our discussion of correlated angles, let's take a look at an angle value where theta is greater than 270 degrees and less than 360 degrees, so it's going to be in the fourth quadrant. And let's say that the terminal arm is located out here this time. Okay, so this is the terminal arm, right? And this has a radius of r if you do a full circle. And the point of this terminal arm will now be positive x and negative y, right? So in this case, the angle value would be a rotation. It's a reflex angle, right? So the rotation would be counterclockwise, and it would extend all the way out here. The related acute angle is always based on the x-axis, so this is your related acute angle. Okay, so this is our angle theta. This is our related acute angle beta, and you can express your value of theta as some kind of expression of, or some kind of equation of beta. And you can write this as 360 degrees minus beta, right? So if you do 360, which is a full circle, minus beta, you'll actually get theta. Okay, so that makes sense. And now in this case, we can understand that if we looked at our first quadrant, right, so this was our first quadrant. One second. Okay, so this, if we looked at angles in our first quadrant, if theta was in our first quadrant, that this would have a point x and y. So this would be y, this would be x, this would be r, right? So therefore, sine theta was equal to y over r, cosine theta was equal to x over r, and tan theta was equal to y over x. And all of these ratios were positive. So we found that all of the ratios in the first quadrant were positive. Only the sine ratio was positive in the second quadrant. And in the third quadrant, we found that only the tan ratio was positive, right? So investigating the fourth quadrant, we're going to assess beta, our related acute angle. So beta was a related acute angle. Once again, just to reiterate, we are using a related acute angle to find values of our obtuse and reflex angles, right? So beta is a related acute angle, and if I looked at beta here, right, this would basically be x, positive x, this would be negative y, And if I looked at my ratios, sine of beta is equal to negative y over r, the hypotenuse, right? Opposite over hypotenuse. And because it's negative, we can imagine here that this is going to be equal to negative sine theta. Okay? Cosine beta is equal to positive x over r, which is equal to positive cosine theta. And tan beta is equal to negative y over x, which is equal to negative tan theta. So this also indicates that one of the ratios here are positive, and in this fact, the cosine ratio is positive in the fourth quadrant. Okay, so this is the fourth quadrant. Okay, so in the fourth quadrant, the cosine ratio is positive, right? And if we wanted to kind of simplify out these related angle equations, we can note that sine theta, instead of writing there, we're going to write 360 minus beta. Sine 360 degrees minus beta is equal to negative sine beta. Cosine 360 minus beta is equal to positive cosine beta, and tan 360 degrees minus beta is equal to negative tan beta. Okay, so these are our related acute angles. These are our correlated angle equations in the fourth quadrant. Now how we use this is, let's say that we want to evaluate cosine, well, let's actually do a different one. Let's do tangent 330 degrees. Okay, so 330 degrees is between 270 and 360, so it's in the fourth quadrant. If we want to evaluate for tangent 330, then basically what we're going to be doing here is going to be utilizing this equation for tan, right? So we know that tan 360 degrees minus beta is equal to negative tan beta. In this case, our value of theta here is going to be equal to 330, right? So all of this here should be equal to 330. So we know that 360 degrees minus beta is equal to 330 degrees. So therefore, beta should be equal to 30 degrees. So if beta is equal to 30 degrees, and if we plug this into our equation, we can imagine here that tan 360 degrees minus beta, which is 30 degrees, is equal to negative tan 30 degrees. So wherever I see beta here, I plug in 30 degrees. Okay? And you can see here that tan 330 degrees is equal to negative tan 30 degrees. And tan 30 we know is square root 3 over 3. And because it's negative tan 30, it's negative square root 3 over 3. Okay, so that's how we can use our correlated angle equations to determine the values or the ratios of reflex angles. Alright, just to summarize for everything we just kind of discussed about a related acute angle, our correlated angles, determining the ratio of obtuse angles, reflex angles of the respective trigonometric functions, we found out that in the first quadrant, all the ratios were positive, and these would be acute angles between 0 degrees and 90 degrees, right? And we can understand here that all the ratios here would be acute angles, so they should all be positive. In the second quadrant, however, we found out that our terminal arm would be between, well, would create angles. Right, our terminal arm would create angles between, theta would be between 90 degrees and 180 degrees. Okay, so here theta was between 0 degrees and 90 degrees. And these would be obtuse angles. Okay, and we found out that only the sine ratio was positive, right? So one way you can kind of determine this is we'd use the modifier beta, which was located here. Okay, so beta would be located there, and if we wanted to represent our angle theta, the modifier here would be theta is equal to 180 degrees minus beta, right? And because we know that sine is only positive in the second quadrant, therefore for the second quadrant we write that sine 180 degrees minus beta is equal to positive sine beta cosine 180 degrees minus beta. So all you have to do really is to memorize the modifier, and you just have to memorize the sign, right? So this is a great way to just kind of summarize through that. I would just kind of sit down, memorize this, and try to do some questions. So you do 180 degrees minus beta is equal to negative 10 beta. Okay? In the third quadrant, the terminal arm existed somewhere here. Okay, so here's our terminal arm, and we can notice here that the angle in question extended all the way out here. So this would be a reflex angle. Remember that we're doing all of these rotations from the initial arm found on the positive x-axis. And in this case, in the third quadrant, theta is equal to 180 degrees plus beta. Okay? And we found out that only the tan ratio was positive in this quadrant. So in quadrants 3, tan 180 degrees plus beta is equal to positive tan beta, right? Sine 180 degrees plus beta is equal to negative sine beta. So all you have to do is memorize the modifier, and cosine 180 degrees plus beta is equal to negative cosine beta. Okay, so that was in the third quadrant. And lastly, in the fourth quadrant, we found that only cosine was positive, and the terminal arm would exist out here, right? And this angle here would also be a reflex angle, and it would extend all the way like that. Maybe we should draw it out here, right? So it would extend all the way out here. Whoops. Okay, and it'd be a reflex angle, and our related acute angle in this case was here. Okay, I think I forgot to mention the related acute angle where you draw it. But you always have to make sure you have a positive x-axis, okay? Sorry, you always have to have an x-axis. It doesn't have to be positive. So in this case, our modifier, in case of finding theta is equal to 360 degrees minus beta. So that's our modifier for quadrant 4, and we found that only cosine is positive. So because only cosine is positive, then sine 360 degrees minus beta is equal to negative sine beta. Cosine 360 degrees minus beta is equal to positive cosine beta, and tan 360 degrees minus beta is equal to negative tan beta. Okay, so those are our correlated angles, and it's good to kind of just memorize this cast rule, the Cartesian plane, where cosine is positive in the fourth quadrant, all the ratios are acute and positive in the first quadrant, sine is positive in the second quadrant when we have an obtuse angle, and tan is positive in the third quadrant when we have a reflex angle. So I would memorize this. I would memorize the modifiers for each of these quadrants, and the next step here would be to do some questions.